A telescope just revealed something that feels impossible. The universe we thought was 14 billion light years across is actually closer to 93 billion light years wide. James Webb looked into what seemed like empty darkness and uncovered nearly 800,000 galaxies hiding there. Galaxies that already existed when the universe was only a few 100 million years old. Black holes billions of times more massive than they should have been. Structures stretching tens of millions of light years when there shouldn't have been enough time for them to grow. Almost everything we believed about the early universe is being challenged at once. If you're ready to see what's really out there, stay with me, because this story starts at the edge of time itself. Light from one of these galaxies began its journey just 280 million years after the Big Bang. It traveled through expanding space for more than 13 billion years before James Webb finally captured it. That galaxy, known as Jade's Dash, GS-Z 14-0, now holds the record for the most distant confirmed galaxy ever observed. Its discovery pushed our view of the universe back to a period when everything was still forming, still unstable, still impossibly young. The universe today is about 13.8 billion years old. This galaxy existed when only about 2% of that time had passed. If the universe's entire history were a single year, this galaxy formed in the first week of January. We are looking at cosmic infancy. What makes this shocking is not just the distance, but the maturity. This galaxy is bright. It is actively forming stars. Its internal chemistry already shows signs of elements that require previous generations of stars to have lived and died. According to older models, galaxies were supposed to grow slowly, carefully, over hundreds of millions of years. This one did not. It formed fast and lit up early. And it is not alone. James Webb was built to see this kind of thing. Unlike older telescopes, it does not rely on visible light. It hunts infrared radiation, which is crucial because the universe is expanding. As space expands, it stretches light waves traveling through it. Light that started as ultraviolet or visible radiation gets pulled into infrared wavelengths over billions of years. The farther away a galaxy is, the more its light is stretched. That stretching is called redshift, and it acts like a cosmic distance marker. That galaxy, known as Jade's Dash, GS-Z 14-0, has an extreme redshift value, meaning its light has been stretched more than 14 times its original wavelength. Older telescopes like Hubble simply could not see light that far shifted. James Webb was designed specifically to solve that problem. To do this, Webb sits far from Earth, nearly 1 million miles away, in a stable gravitational location where it stays permanently shaded from the Sun and Earth. Its instruments are kept colder than Pluto because warm objects glow in infrared and would drown out faint signals from the early universe. Its massive, segmented mirror, coated in gold, collects incredibly faint light, allowing it to detect galaxies hundreds of times fainter than what was previously possible. When Webb stares at one patch of sky for hours or days, photons that left galaxies billions of years ago slowly accumulate. One by one, ancient particles of light build an image. Spectrographs then split that light into precise wavelengths, revealing chemical fingerprints and exact distances. This is how astronomers know these galaxies are real, distant, and ancient. Not guesses, not theories, measured facts. What truly unsettles scientists is how common these early galaxies appear to be. Before James Webb, models predicted only a handful of bright galaxies in the first billion years after the Big Bang. Webb found hundreds. In some surveys, it found 10 times more early galaxies than expected. The early universe was not quiet or empty. It was crowded, active, and building structure at a pace no one predicted. Then come the black holes. Inside, several of these early galaxies are supermassive black holes that should not exist yet. Some weigh millions or even billions of times more than our Sun, appearing less than 600 million years after the Big Bang. According to standard physics, there simply hasn't been enough time for black holes to grow that large through normal processes. Even feeding at the maximum theoretical rate, they should still be much smaller. Yet, James Webb has confirmed black holes that are not only massive, but feeding at rates that appear to violate known limits. One black hole has been observed consuming matter at more than 40 times the rate physics says should be possible. Radiation pressure should push incoming material away, creating a natural speed limit. This black hole ignores it. It is gorging itself. These discoveries suggest that black holes in the early universe grew under very different conditions. Some may have formed from the direct collapse of enormous gas clouds, skipping the normal star phase entirely. Others may have experienced short, violent feeding frenzies that allowed them to gain mass rapidly. Some galaxies show black holes so massive that they outweigh all the stars around them combined. The usual balance between galaxies and their central black holes appears reversed in the early universe. James Webb has also revealed something even stranger. A supermassive black hole racing through space at nearly 2 million miles per hour, torn from its home galaxy and leaving a 200,000 light-year trail of newly formed stars behind it. As it plows through intergalactic gas, it compresses material, triggering star formation in its wake. This is the first confirmed runaway supermassive black hole, and it proves that galaxy mergers in the early universe were chaotic and violent beyond expectation. And mergers were common. Webb has detected pairs of supermassive black holes spiraling toward each other in galaxies that existed less than 1 billion years after the Big Bang. These black holes will eventually collide, releasing enormous gravitational waves. Such mergers help explain how black holes grew so massive so quickly. Instead of slow feeding, some gained mass by colliding and combining. The telescope has also revealed galaxies forming stars at absurd rates. Some young galaxies are creating stellar mass hundreds of times faster than models predicted possible. Entire galaxies appear to be star-forming furnaces, converting gas into stars with extreme efficiency. This suggests that the early universe was far better at building galaxies than we assumed. Gas collapsed faster. Feedback processes that slow star formation today were weaker or absent. Perhaps most haunting of all is the possibility that Webb may be seeing galaxies dominated by the very first stars. These primordial stars, made only of hydrogen and helium, would have been massive, short-lived, and intensely bright. They ended the cosmic dark ages by flooding the universe with light and forging the first heavy elements. Their existence has been predicted for decades, but never confirmed. Some of Webb's observations show galaxies with almost no heavy elements at all, hinting that we may be glimpsing systems powered by those first stars or their immediate descendants. All of this feeds into a deeper mystery. The universe is expanding, but we still do not agree on how fast. Measurements based on the early universe give one expansion rate. Measurements based on nearby galaxies give another. James Webb confirmed that this discrepancy is real. Something is missing from our understanding of cosmic expansion. Dark energy may behave differently than we think, or there may be unknown components of the universe we have yet to discover. Then there is scale. In one survey, James Webb stared at a patch of sky about 3 times the size of the full moon and found nearly 800,000 galaxies. That is a microscopic fraction of the sky. If that density holds, the observable universe contains over 2 trillion galaxies. Trillions. Each one with billions of stars, each one potentially containing worlds. Hold a grain of sand at arm's length against the night sky. The area it covers contains thousands of galaxies. This is not metaphor, it is measurement. The universe is so vast that numbers lose meaning, and yet we are here looking back across 13 billion years of time. The atoms in your body were forged in stars like the ones James Webb is observing. The iron in your blood, the carbon in your DNA, the oxygen you breathe all came from ancient supernovas. We are made of matter, shaped by processes that began in the cosmic dawn. We are not separate from this story. We are a continuation of it. James Webb has shown us a universe that grows faster, burns brighter, and evolves more violently than we ever imagined. Galaxies formed early. Black holes grew fast. Structures emerged quickly. The early cosmos was not patient. It was intense. Every discovery raises new questions. Every answer breaks an old model. That is how science works. We approach truth without ever fully reaching it. And that is the beauty of it. We are small. We are brief. We live on a tiny planet around an ordinary star in an unremarkable galaxy. And yet, we have built machines that can see the universe as it was near the beginning of time. We have become matter capable of understanding matter. The universe looking back at itself. James Webb is not just showing us distant galaxies, it is showing us how little we truly know and how extraordinary it is that we can know anything at all.